Well, good afternoon, everybody, and thanks to the London section for inviting me back. If I seem a little bit nervous, it's because Nick has scared the life out of me by what I saw this morning. Salutary message for all of us to take back. Secondly, just remind me how many people have been out on the track in the last 3 months. Right, challenge. Next London seminar, see how close we can get to 100%. Okay? Right, ballasted track renewal. How to, or perhaps how not to. Please don't try this at home. It's quite good because some of the themes, particularly what Thomas spoke about this morning, are replicated in my paper this afternoon, and you will see there's a common theme going through this seminar, and coincidentally nobody got their heads together beforehand, so it's quite good that it overlaps in that way. Factors for consideration we've spoken about. I'm speaking here today. I am the maintenance engineer amongst renewal people, so what you are going to build is what I'm going to get back, and I ain't going to sign it back if it's not what I wanted in the first place. Okay? Known as Mr. Nasty up north. I'm sure you've all been there. Again, there are a number of areas to address when we're talking about ballasted track renewal. I can't do the whole subject justice tonight, this afternoon. I hope to give you a flavour of some of the areas that we're going to look at. And it's not just about sleepers and rails. What we're looking for, in summary, is a really good formation, preferably with a crossfall on it. Do remember that. A good blanket or geotextile, where we specified it, and a good depth of ballast. When we say in that scope of work 300 millimetres of ballast, or 250 millimetres of ballast, that's what we mean. And remember, the maintenance engineer is going to go out there with a shovel and dig a hole under that sleeper personally, and if it's not that depth, he's not going to take it back. Okay? Again, we need to get the bottom ballast correct and good as that, because that's going to determine how long that track's going to last and what quality it is. On Nexus, we specify 3D laser control on all doses when cutting formations and preparing bottom ballast. And yes, I have a very similar spirit level in my office, which still gets used, nailed to a piece of wood. Yeah. And we do use track tex in our blanketing works because that saves us some additional materials handling. As you saw earlier this morning, detailed investigations will be required. The track tells its own story. It's not just poor cropping alignment, something is not quite right under there. We need to look at integrity. We've heard about standards, and there are many, many standards. We need to look at compliance. When I joined Nexus in 2007, the photograph on the left was my first day out, and I went out on my first day with the track supervisor and asked him why it didn't have a speed restriction on, and when was it in the renewal programme this year, when was it going to get done? And he said, well, I hadn't planned a speed restriction and it isn't even in the programme. So that didn't go down too well. We've got to look at integrity and compliance all the time. Contaminated ballast. On the route, a legacy from the old British Rail steam days. Base plates with elongated holes in them, water sitting in the formation, and clay pipe drainage that's absolutely solid. So not a good mix from a maintenance point of view. Factors for consideration. You know, you go from the lower end, where we're looking at speed and tonnage and frequency. And maybe that one should have had an earlier proposal. But we look at the high end, safety, reliability and durability, you know, the highest qualities. So practical track renewals covers that whole spectrum. We touched on this morning, how do we justify track renewal, capital versus maintenance? Well, we have a whole wealth of information that informs us. Sometimes, as you saw this morning, we think there's too much information there. But you can't beat looking at the the stuff from the guys on the ground. Look at your asset intelligence systems. We use Maximo. Look at where your faults and call-outs are. Have a desktop review, but above all, get that foot on the ground and go and have a look. Right? You can't make it up in an office. Okay? I go out to find out why my best eighth of a mile of track, my most maintained eighth of a mile of track, is next to the beach at Whitley Bay. And there's an awful lot of maintenance done in July. You can't beat going out. Different ways of measuring it. Obviously on Network Rail they have the NMT, very impressive piece of kit. Overseas they have a whole range of track inspection cars which do a very similar job. From that we use Maximo, and I won't go into it in detail, but this gives us all the faults in all my disciplines and all the planned maintenance. I can switch this system on every morning and tell me how many faults I had yesterday, which ones are past their sell-by date. I can then press another button on the phone and ask whichever engineer it is to pop along and please explain why he didn't rectify that fault in 24 hours or whatever it might be. From that data, we then get asset failure reports. We look at, we call work blocks, but eighths of a mile. Which eighths of a mile are giving us the biggest problems. From that, it's not rocket science. Introduced very quickly 1196 form, and all my forms at Nexus are numbered in military style. Makes it very easy to retrieve them. This is a simple summary of that eighth of a mile and what's required to put it right. So from this we would develop that full scope that Thomas spoke about this morning. Okay, you can't beat, as I say, you can't beat getting out on the track and having a look yourself. But get out on night shift, get into the cab of that tamping machine that you've paid millions of pounds for, find out why the operator can't get his cross level, why he can't cure that twist. It's all about getting out. Strategic considerations, we talk about possessions. We have control of the line, which is normal weekday nights. We have possessions, we have blockades, and then we shut the thing down for 27 days and have a huge jamboree. Everybody goes and then does all sorts of things. We've got a lot of interfaces. Biggest one, of course, the greatest football team on the planet, Newcastle United, who finished above Sunderland in the league this year. I must just remind you of that. But we have 52,000 people every Saturday afternoon, so we obviously don't want to shut the metro down. We run parallel to Network Rail. So obviously we work closely with Network Rail when they're doing their track renewals. We don't want to shut a parallel line and cut the customer off completely. So it's all stakeholder involvement. We've brought in a new system. We've split the metro, which runs from the airport up here down to South Shields, and then from South Gosforth round the coast, past that wonderful eighth of a mile of track at Whitley Bay, and to the centre of the universe at St James's. We've split that into 6 sections, so we can actually take possession of these sections every night. The protection goes in the same place every night. The paperwork for the possession is the same every night, so people can't misinterpret. We isolate between substations, so we actually go in and switch in the substation, so we don't send guys out down the track in the dark with a torch looking for a box to switch. So make it all simple. It's not difficult. Where we need to, let's say we're rail grinding or tamping over 2 zones, we just stitch the 2 zones together under one pipe up. For a jamboree, 27 days. For us in the northeast, that's half our system shut down, so it's quite an intensive bus replacement service that we need. You just can't go and get huge fleets of buses, on a phone call. So these all came from London. Our train operating company brought them in. The buses were geared for 45 mile an hour. They were so comfortable, and the drivers preferred the gearboxes on them that they remained in the northeast, and they've got rid of the other fleet. I don't want any bendy buses, thanks. Specific considerations, we need to look at the site context, which we've heard about from London Underground this morning, equipment availability, methodology, access and logistics. So if you're shoving a track relaying train into Gore Canyon in Colorado, logistically it's a bit of a challenge. You are probably 300 or 400 miles away from somewhere, so you don't want to leave your rail pads or your pandrel clips back at the depot. I was fortunate enough to be out with the train for a while, but safe systems of work, it's all there. Budget considerations, we touched on that this morning. Is it revenue? Is the maintenance engineer just going to make some minor improvements? Is he going to get some capital maintenance money, what we like to call the slush fund, where we get a chunk of money but we never actually say what it's for, but it's always gone at the end of the financial year anyway. Capital projects, which are standalone capital projects, and we currently have our ERP asset renewal plan, which is a £400 million injection into the system to rebuild it over 11 years. So, quite a range of funding streams there. But you want value for money. We touched on design. Is it like for like? Are we going to do some upgrades? Should we future-proof it for enhancements down the line? Are we going to improve the geometry and speed improvements, clearances? And are we going to improve DDA and RVRA compliances? And above all, is it going to be maintainable in the future? Or is it going to require some really sophisticated kit to keep it going? Interfaces, as I said, level crossings as one example. You've obviously got the highway and the railway interface, a range of profiles, but you generally also got a lot of utilities there. Delay this by an hour. Yeah. So you've got a whole range of utilities, so there's an awful lot of research to do at those locations before you actually put a shovel in the ground. Yes, the Tilton train will hurtle through the platform at a great rate of knots, but will the stopping train achieve compliant clearances? So the designers have a lot of head scratching to do in those circumstances. Stakeholders, there's a whole lot of stakeholders, which I won't read out, and there's probably a lot more, but to put that into perspective, I can't put orange flashing lights, orange jackets and 360s with jibs under the end of the flight path at Newcastle, so I do have to liaise closely with the airport. The last thing you want to do is be landing from Dubai as a pilot and seeing a 360 moving in front of you, 10 foot below you. So it is a big interface. We also run parallel with Network Rail, north and south of the river. That brings its own challenges in terms of safe working, as it does for Network Rail. So there's a close interface there. We'll have a look at some examples, because I know a picture tells 1,000 words, and that's the best way to get it across, so we'll look at a range of things. First of all, do we actually need to do a track renewal? As I say, when I went to Nexus in 2007, first thing we did was some basic P-way engineering, some heavy maintenance, which was getting the components right, getting them tightened up, spot sleepering, getting some ballast down, and making it tampable. And that buys you a few years and saves you a few bob in the long run. So before you launch into renewal mode, you can actually do a lot of fixes yourself as maintenance engineers. What? I had to bring that one down to London. Yeah, couldn't resist it. Of course, manual relaying, big drain on manpower, quality's not particularly good, and it takes a long time. One of the things that we don't do on our railway that we did several years ago, I don't see much evidence of it now, is lowering the cess. If you lower the cess, it's pretty simple. If you lower the cess, you let the water out of the railway, and water is the permanent engineer's biggest enemy. And we used to do cess lowering. We did the whole of the Whitby branch, the Bishop Auckland branch, the coastal line around Middlesbrough. Lots and lots of good work there that kept those railways going for years. But I don't see a lot of ditching done now. I see a lot of blocked drains and a lot of flooding reported on the railway. So that could be a simple fix. The right-hand machine was invented by a horrible mechanical engineer who had a hatred of permanent way engineers. I'm sure they'll not just dig a ditch, it'll chew an awful lot of other stuff up as well. We then move on to excavation, which is actually removing it and getting rid of the old track and ballast. So we rough dig on Nexus with a 360, with a rotor tilt blade, and put a rough crossfall on it. Then we take the top layer off with a 3D laser dozer, and we put in the bottom ballast with another tracked 360, not a rubber tired 360. Then the dozer levels that, we consolidate it, and we whack it down with triple whackers, which are remote controlled to avoid obviously the issues with hand-on vibration. So the right-hand side is what we need to have before we put any sleepers on it at all. So that's a track excavate. We can reballast using mechanical or automatic ballast cleaners, which have a cutter bar that go under the sleepers and chew out the ballast, and either throw it to the cess, as you see there, overseas, or put it in spoil wagons or behind themselves in material handling wagons. What you don't want to do with your ballast cleaner, of course, as many of you will know, is actually dig into your formation, because you can actually make your track much, much worse. So the skill is in controlling that cutter bar. And also how you ramp in and ramp out, because if you don't get it right or you don't build a ramp, you will feel that transition from new to old for many, many years to come. These machines have got bigger and bigger and gone into high output mode. They can really chew the track up and move large quantities of material. But again, you don't want to be cutting into the formation. If you do want to cut into the formation, then you need something like a formation rehabilitation train, which will actually take the whole lot out and start from bottom and build it back up. Not something that we've really got in this country currently, but someday I'm sure we will be going along that avenue. Another innovation is reballasting by vacuum, relatively new to the UK, but used in Europe and used overseas. I would suggest it's probably got to prove itself yet, but it's good where you need to get in quick between trains and do short areas. It's used in the States on a regular basis, and of course it only takes 2 guys to operate it. So something for the future, probably. If we go back to manual then, you can, of course, lay 10 miles of track by hand in a day. Don't think anybody's ever beaten that record, but it's still practiced. We still do manual track relaying. But in the early days of British Rail, to speed it up, we developed craneage, twin-jib track layer cranes, and we reverted to what was known as panel relaying, which is, as it says, lifting out a whole panel. You can do it with a crane, or you can do it with a twin-jib. Many of us will have stood there as a sleeper has dropped off and whistled by your shoulder. Not the best place to be. What problems do we have with panel relaying? Well, we're taking one panel out and we're putting another panel back. So whatever the memory was where the rail joints were, we've probably replicated that or not moved them on. There's additional work in changing panel rails to CWR. That causes extended speed restrictions and longer possessions, more possessions. The twin jib, of course, needs two tracks for its possession. And there's an awful lot of work lining joints on curves. One day we used to be able to measure the outside rail and the inside rail and cut them exact and have them pre-curved and pre-measured and delivered to site. These days we send them as standard 60-foot panels, and somebody gets a disc saw out and cuts a lump of metal off the end. So we seem to have lost that art. The more you pre-curve the joint, the more you pre-curve the panel, the more chance of the load being out of gauge. That brings logistics problems into delivering it to site. And then if you don't pre-curve it, when you put it on the ground, you have an awful job lining the joints up. So your future alignment is going to be pretty poor. There are other ways of doing it to keep it on a single line to allow the adjacent line to remain open. There are panel gantries of various configurations. Some run on the ground on Caterpillar tracks, other ones run on slave rails on the outside. That all takes extra work to set those up, so it's all additional work. Or you can have an innovative solution like this, where you've got a tractor unit that holds the gantry forward. Problem is, you've just gone and spent an awful lot of time and effort making a perfect formation, and then you're now running a rubber-tired truck on it. So, you're causing yourself even more problems. The ultimate top-of-the-world gantry relaying in Tibet, end-over, flat-off type track lane machines, huge panels. They put them down in bite-sized chunks that reduce the number of joints. But again, when you come to a curve, you struggle to line that huge panel up. So that gives them problems. So quantity isn't always quality. There has to be a balance. At Nexus, I much prefer loose sleeper relaying because we get the alignment and the level right first time. So the quality goes in straight away. Mechanical panel grab, one man on the machine, one man on the ground. That's all we need. And we just go off and roll it all out. So it makes it very easy. How not to do it. This is actually in Australia. A rubber-tired crane for off-road sleepers, so he's destroying the formation. There's a dump truck or something behind him, and if you look at the way the sleepers have been put in, they're going to have a devil's job getting the rail in there and lining all of that up. So they've just made themselves an awful lot of work. Again, in New Zealand, and a site we're all familiar with, they've done all that work and all that effort, and they're now having to lift the sleepers with bars and tongs, and even the excavator spacing them to get them up and get the rail clipped up. So where you've gained an hour or 90 minutes on your program, you've now just lost 2.5 hours in clipping it up. And if you use rubber-tired vehicles, then you'll end up with a track looking like that. When it looks like that, that's extra work for your tamper, that's extra time on your tamping shift, extra strain on the tamping machine. You're probably going to blow a hose or something with the pressures you're using on that. Slinger train and steel sleeper relaying, it's even more critical that you get these lined up correctly in the first place, because once you've dumped the ballast on top of them, as you all know, they won't move an inch. They're not designed to move. So you're only going to break your tamper. Your long welded rail train is probably the heaviest train on the system. Right, so get its route and its path correct. Make sure the bridges it's going to go over have been assessed and checked. It's no good getting halfway down the line on a Saturday night and finding out you can't get to your site. Please avoid the pull apart. It's a bit of a mess to sort out. You don't want one of them on your patch. You can't couple anything to it, and some poor guy's got to burn all the ends off them. So you've got yourself another 24 hours work already. So don't overload the long welded rail train. Don't try this at home, but unloading long welded rails with excavators is a no-no. Right? Don't tie the excavator to the back. All that happens is that the rail rolls over on its side. So you've then got to spend the whole shift standing the rail up on its rail foot. You should, of course, use the properly designed kit. Thimble and rail, you're all probably experts at thimble and rail. And as you know, the greatest tip in the world is you've spent all night preparing that ballast bed, you've laid all those sleepers evenly spaced, and then somebody comes along with a road railer and knocks them all over the place. What you need to do is put one rail in the forefoot, put some dead weight on those sleepers so they don't get knocked about, put one rail in, and then put the rail in the forefoot on the other side. Save yourself an awful lot of time and effort. And the guys won't scream at you either. Let's mechanise the process. In another life, I was a dinky skinner on a track relaying train, but what a fantastic job that would have been. Have that on your armband, dinky skinner, right? But manual sleeper relaying in these conditions was very onerous, so the guys quickly decided to mechanise it. And the philosophy hasn't changed much over the years. The same process where we drop the tracks in front of the machine on virgin ground, and then we just feed all the materials through and pull the rails out in front. That gives us a carpeted railway ready for ballast and tamping. Slight variation. We can pull the same train with a bulldozer, or it can self-propel, but the technology and the philosophy is the same. So different ways of doing different kinds of renewals for different sites and different contexts. What does that mean? It means the quality's improved, the quality's higher. It means these guys, the welders, they don't have as much effort wedging the rail up and lining and leveling the rails, so that's a big time saving, a big cost saving. It means they're not whinging at you, and it means you get good quality welds at the end of the day. It also means if you're using the flashbutt technology, that the machine has less strain and less effort picking those rails up. So again, attention to detail and quality. Then we move on to the big boys, the track relaying train. As many of you know, it will beats as it sweeps as it cleans. It picks up the old track and renews it with new track. A mobile logistics platform. If one element goes, the whole lot goes down. So you need to be on top of your game with it. But the quality is unbelievable behind it. So there we have the old tie pickup, picking up the old sleepers beneath the machine, the new sleeper installer, feeding them down the conveyor and swapping the rails over, and the rail warmers heating the rail up to its stress-free temperature before it's clipped down. All in one go. I'll say I had the privilege to work out in Colorado with the machine before we brought it onto the West Coast main line. Now, if you look at this picture, that's the quality immediately behind the track relaying train. All the guys are doing is picking up muck and bullets and a whole load of rubbish. Then you need a ballast train. Usually some underpowered, clapped out old loco from the back of the shed that couldn't pull the skin off a rice pudding. Where's Mr. Brunel? Yeah. Yeah. And we got the same from George Stevenson, so don't worry. Somebody mentioned side tipping wagons earlier on. I had many a happy shift cranking the mermaid wagons up. The philosophy hasn't changed much, but the systems are far, far better. And when we talk about safety, I remember the York office developed a pneumatic impact wrench that would rotate this handle. And it came out to Northallerton one Saturday night, and a guy put it on the side of the wagon. And it flung him 360 degrees and killed him instantly. Yeah. So that was the end of the mermaid wagons on the eastern region. Standard method is ballast hoppers, right? Probably one of the most dangerous activities you can get involved in because it's a moving activity. People, by their very nature, will jump on and off these moving vehicles. The ground conditions are pretty uneven. You need to avoid it at all costs if you can. Thankfully, we've moved on to an age of self-discharge auto ballaster wagons, which take that human interface away from being on the ground. But the future is the plus train and the smart train, where we do a computer survey of the whole route. We put that into a laptop, we sit on the locomotive, we plug it into these wagons, and we run through the route at 40 miles an hour, and we discharge the whole train, and it shuts itself off when it comes to an obstacle like a level crossing or a bridge, and then restarts at the other side. No human interface on the ground or on the wagons at all. 2 guys on the locomotive, 1 technician, 1 driver. Smart technology is an inertial system which allows it to do the same through a tunnel where it would lose the GPS signal. High output kit, as I say, as you know, they tend to come with their own custom built materials handling systems, pretty self-contained, but able to move materials, high volumes of materials very quickly. How do we spread it? Well, we used to spread it with a plough, and the blade wound down very easily, but it didn't used to wind back up very easily. It used to cause all sorts of problems. And I remember many a happy shift 609 gang propelling me through Newcastle Central Station, shouting to the people on the platform, left hand down a bit as they turned the wheels. We used to have great fun on those days. Conversely, I've seen a number of PWA staff flung out the back as the train set off back for home. So, you know, not the best thing to do. So you want a ballast regulator, two main components, ploughs and brushes. Not much more you can say about them, but they come in a range of configurations, and these were the ones we commissioned for Grant Rail as it was, the R24s. So they do the profiles. Now, from a maintenance point of view, the ballast regulator is one of the most efficient machines you can get, right? Because we dump thousands of tons of ballast per year, but we actually can recover a lot of ballast, and we don't seem to do that. So that's a big thing for us on Nexus. The same with your tamper. You can have too much stone, which will just clog up his gear, and he'll come to a stand, and he'll be hitting all those new concrete sleepers that you've put in, chipping away at them, causing damage. Too little, you'll punch his tools right down to the bottom, pull the limit switches out of the tamping banks and grind to a halt. So your £3 million machine's now stuck there in the middle of your track renewal site. So the quantity of ballast is pretty important. Alignment, we control with the various range of systems. Our older tamper at Nexus had this scaffold trolley on the back to get us up to 4-point lining, which is more accurate. We do have a laser lining system for straight track. Most modern machines have a track geometry control system, computer-based system, that makes the job a whole lot easier. But however sophisticated these machines are, and however expensive they are, if you haven't got the ballast right, it won't deal with it. It won't deal with it. So that's what we've got to look at. Just to finish off, at Nexus, the big thing for us, we have a 12.5-ton axle load over many of the bridges. We have a very unique structure gauge, so we can't get big locos, big wagons, big tonnages on the system. So we have to do it by Unimog and box wagon trains. The cycle times for us are quite incredible. So there's one blockade, which was 108 trains for spoil and 123 cycles for spoil and 120 cycles for new ballast in. So quite a logistics challenge. However, we overcome that by a little bit of innovation using NICS, the non-intrusive fold-away crossover system. That immediately improved our cycle times by 50%, okay, which is a massive saving on a 27-day blockade. And we've used that to great effect. You simply fold the flaps over, it becomes a crossover, you fold it back the other way, clip it out of use, and you can run your normal trains during the day. Fantastic innovation that we've used. To sum up, you know, you've spent all this money, all this time and effort on track renewals. Don't let it go to waste, right? Keep on top of it. Keep the top, keep the line. Keep it reliable, keep it durable. And the only reason I say that is it's just an excuse to put a photograph of a new shiny tamper up, which we've just had delivered to Nexus. Universal plain line and S&C tamper. But that's why we've invested in that. We're investing £400 million in infrastructure renewals, a lot of which is going on the permanent way. So we need the right gear to maintain that permanent way in the future, to keep it to that quality. We have a philosophy, right first time, right every time. Otherwise I won't accept it. I know I might sound awkward, I might sound blunt, but it's not in anybody's interest to accept a substandard product. You wouldn't accept it from a telephone company, you wouldn't accept it from Sky TV, so why accept it on a track renewal site? Thank you very much.